We received UK CARES pilot funding to purchase a UAV-compatible gamma spectrometer that we expect will become a useful tool for identifying areas with high radon potential. Much of the work you'll see today comes from the master's research of KGS graduate research assistant and UK EES graduate student Alex Thomas. Alex won a student poster competition first place award for her work at this year's Geological Society of America annual meeting in October. The spectrometer was designed specifically for UAV applications. Data can be processed to identify uranium, thorium, potassium, and total gamma counts. Our work to date has focused on understanding its resolution and precision before using the spectrometer in complicated geologic settings. Our initial test showed counts in the uranium range are very low in our geologic setting. Ultimately, we'll need to work on that. For now, we'll stick with total counts as an indicator of gamma radiation and indirectly radon potential. To evaluate environmental effects, we used a portable X-ray vest to shield the unit from sky and ground during stationary tests. Our results suggest that the cosmogenic environmental effects are minimal. We repeated stationary tests at the same location on the ground. Our results suggest that stationary repeatability is high and the uncertainty is tolerable. We also repeated hand-carried profiles along designated lines. Our results suggest that mobile repeatability is also high. We obtained hand-carried profiles along lines crossing different kinds of ground surface to simulate geologic features like faults juxtaposing different rock types. Our results suggest that we can distinguish different ground surfaces and, we hope, detect geologic features. Here's a stack of several profiles repeated across an asphalt road with soil on each side. We're using geophysical processing techniques to combine the profiles and cancel random noise. Multi-altitude tests show the already weak uranium signal decreases with height above the ground. This may place significant operational limits on the UAV spectrometer. The higher the flight, the larger the on-ground footprint. A series of multi-height profiles shows how a sharp feature boundary is blurred as the height increases. Our preliminary results suggest a low maximum flying height, likely 10 meters or less, may be required. This series of profiles again shows the difference between ground cover types, attenuated and blurred as height increases. Thank you for your interest.